Our last video introduced the logarithm function ln x. It's the inverse to e to the x. We graphed it and wrote down a couple of properties, but in this video I'd like to expand and write down even more properties of log x. So before we begin, recall that e to the x and log x are inverses. And what that means is that if you have an logarithm inside of an exponential function, you can imagine that they cancel each other out and you just get back what you started with, x. Or if you compose them in the other order, like log e to the x, you can cancel out adjacent log and e and get back x, what you started with. So let's write down properties. So property 1 is the following. Notice that e to the log a plus log b can be simplified using properties of exponents. So basic properties of exponents says that addition in the exponent becomes multiplication. You could write this, in other words, as e to the log a times e to the log b. Of course, e and log are inverses, so if you see e log a, that's just a, and if you see e log b, you just get b. What I'm going to do is take this line that I just wrote down and apply the logarithm to both sides. So apply the natural logarithm log x to both sides. If you apply the logarithm to this side, so you take log of this whole thing, e and log are inverses. They undo each other. So this side becomes log a plus log b. And then if you take log of a times b, well, I don't know, you just get log a times b. So this is one of the key properties when you're dealing with the natural logarithm function. Log of a plus log of b is log a times b. So the logarithm turns multiplication into addition. A similar property is as follows. If you have e to the n log a power, then properties of exponents says that you can write this as e to the log a to the n power. When you exponentiate here, you multiply the exponents. Now e log a, again, e and log are inverses, so they undo each other. This just gives you a to the n. So now I have a new expression. I can apply log x to both sides. If I do that, log of an exponential cancel each other out. This side just becomes n log a. And then if I take log of the right side, I get log a to the n power. This is another famous property of logarithms that I'm hoping that you'll internalize. Both properties 1 and 2 come from analogous properties in the exponential function. So what I did to get properties 1 and 2 was just to take a known property of exponents and apply log to get a new property involving logarithms. Now, those are the two properties I wanted to get across in this video, but there's also a property that I'd like to not get across. This is not a property. Instead, this is a common mistake that I've seen a lot of students make when they're first trying to understand logarithms. Log of a plus b cannot be simplified. That's not what I have up here. What I have up in this first property is log of a plus log of b separately. If you have log of a plus b inside the parentheses, you cannot simplify it. It is definitely not equal to log of a plus log of b, even though I've seen this repeatedly in student work. They really hope it's true, but it's definitely not. This is not equal to this. The reason why you could see it's false is by just plugging in your favorite cases for A and B. For example, if you plug A equals 1 and B equals 1 into this expression, you get log of 2. On the other side, you get log of 1 plus log of 1. And from the graph, we know that log of 1 is equal to 0. So if this were true, it'd say log of 2 is equal to 0, which is just garbage. Anyway, don't make this mistake if possible. Let's do some examples using properties 1 and 2. So let's say I had natural log of 4x squared. How does this simplify? Well, I could write this as log of 2x squared. Now I'll use property 2 with n is equal to 2 and a is equal to 2x. This becomes 2 log 2x. I could even go one step further because I have log of a product 2 times x. If you'd like, you can write this as 2 times log 2 plus log x. So logarithms turn multiplication into addition. Let's do another example. In this first example, I took an expression and kind of made it bigger. Let me take a bigger expression and maybe make it smaller. What if I had log x minus log y? Well, the first thing I'm going to do is I'm going to write this as log x, watch this, plus log y to the minus 1 power. So check that out. I had a minus sign in front of log x. That's similar to n equals negative 1. So I'm taking n equals negative 1 in this property 2 and allowing myself to put the negative sign on the exponent. So that's a very nice property of logarithms. Now we will use property 1. So property 1 says I can write this as log x times y to the minus 1 power. And I believe that's about as simple as you can make it. You could write it a little bit different if you choose and write it as log x over y if you'd like. So there's another simplification. Why don't I do one more of these to finish the video? So how about if I had log of the square root of x squared plus 1 all over x. For this one, I'm going to notice that I have log of the square root of x squared plus 1 times x to the minus 1 power. Logarithms turn multiplication into addition. That's property 1. So I'm going to use property 1. And also I'm going to use property 2 at the same time. This square root function is a 1/2 power. So taking the square root is the same as raising that expression to the 1/2 power. So I'm going to factor out a 1/2 log x squared plus 1. I'm going to turn this multiplication into addition, and then I'm going to pull down the minus 1 to write it as minus log x. So there's another way to write down the same function. Now, if you continue on in calculus, or if you're working on these types of problems in the book, and you look up solutions to the exercises, sometimes the solutions or the way that they write the logarithm function does not look like the way you have it. That doesn't mean you're wrong, because there are a lot of ways to take a logarithm and write it in a different but equivalent form. Okay, wonderful.